So in the last video we have studied that how the particles move in the liquid state. Okay, now in this video we are going to discuss about the movement of the gas particles. Okay, now see here, how can we demonstrate the movement of gas particles that cannot be seen with the naked eye, because the particles will be very smaller, okay, that we cannot see with the naked eyes. So how we are going to understand in this topic? Okay, for that let us perform activity 7.9. Light an incense stick in one corner of the room. So in the room, what we have to do, at the one side, at the one corner of the room, we have to light the incense stick. Okay, wait for a few minutes and observe. Do you notice the fragrance from a distance? Yes or no? That we have to find the answer for this. Okay, now see here, when an incense stick is burnt in one corner of the room, what will happen? Initially, the fragrance will be felt only around the incense stick. Only the surrounding of that incense stick we can feel that fragrance. But shortly after some times, what will happen? You can smell that fragrance throughout the room, because up to that what will happen? Complete the throughout the room it will be occupied by that fragrance here. So this happened because the particles of fragrance spread and it is filling the entire room. So particles, what will happen? It will start spreading. As we have studied already, the particles in the gases, it will be moving randomly in all direction, right? So filling the entire room. This shows that the particles of air are moving constantly. So from this, so how it is particles of the fragrance which is moving? It shows that the particles of the air which is moving constantly. So how it is moving constantly? The air particle hit the particles of the fragrance. So here we are having two types of particles, what we are studying in this. One is that the particles fragrance, and another in which is air which is present in the room. So what will be happening? Air particle, and here it is the fragrance particle. It will be hitting like this and it will be spread throughout the room. Okay, so and help them spread throughout the room. So which one is helping to spreading? So air particle which is helping to the particles of the fragrance to spread throughout the room here. Okay, oh, now I know why and how the fragrance of perfume reaches us. The similar way it will reach us. Okay, now can you again share a few other real life situations where you have experienced in movement of the gas particles, that you can discuss with your friends and you can share things. Okay, based on our learnings from this chapter, we can say that matter is made up of small particles, that only we have studied. Very small particles is nothing but constituent particles which are held together by the force of attraction. So wherever the particles will be holding together, no, it will be having kind of force, that is force of attraction between the particles. The strength of attractive force between the particles depends on the distance between them. And here the attraction between the particles which is depends on the how much the distance it is there between the particles. Okay, so which is turn depends on their thermal, or thermal is nothing but heat energy. Thus is the thermal energy of the particles that determines the physical state of matter. Okay, we'll see. In the solid state, the thermal energy of particle is very low, so they remains close to each other. Here the heat energy is very less, that's why the particles are very close to each other and experience a strong interparticle attraction between the particles, that is interparticle attraction forces. This restricted their motions to only small vibration. That's why particles movement will be in the solids which is restricted. It will be not moving, only it will be vibrating in its position. Okay, so at the melting point, the thermal energy is used to overcome to attractive force between the particles. So what will happen? For example, if I am taking about the ice now, when we will start supplying a heat or thermal energy, it will start melting. So after supplying the heat energy, what it will happen? Whatever the it was having the force of attraction, no, it will start getting loosened there. So then the particles, it will start getting separate. Then it will convert to from solid to liquid here. So at the melting point, the thermal energy used to overcome the attractive force between the particles, allowing the solid to change to liquid here. Okay. At this stage, the particles can move away from their fixed position. Now it is not in the fixed position, it's become a separate. The distance between the particles become a far. Then what will happen? The particles, it will start moving. Okay, so in interparticle distance increases slightly and it's reduce the strength of the attractive force to the level that allow the particles to move around here in the liquid. So still within a limited space only. I'm talking about liquid now. Okay, so in the gaseous state, what will happen? The particles have enough energy to overcome the force of attraction between them and move freely in all directions. Okay, you will learn more about these particles that constitute matter in the higher grade here. Now let us warm up particles nature of the three states of a matter. So what and all we have studied in the chapter now. Here it has been given. Here it is solid, liquid, gases here. See here in a solid, interparticle spacing is very minimum, and whereas in a liquid it is having a space which is a little more than the solid if you are comparing. Okay, and space is very maximum in case of gas here. In a solid, particles are very closely packed, and here it is little loosely packed if you are comparing with other solids, and particles are very free, I mean in a free state. Now interparticle attraction is very maximum. Why it is maximum? Because which is a closely packed, and here interparticle attraction is slightly weaker if you are comparing with the solids, and here it is a minimum, or we can say negligible, I mean no, not at all. Now movement of particles is negligible. There is no movement of a particles in solid, but vibration will be there. Okay, remember. So movement of particles restricted to only in the limited space. Okay, but here movement of particles in all the available space here. Okay, in the next class I'll be covering the question answers from this chapter. Okay, thank you.